For this tutorial, we are going to demonstrate setting up a simple AI command as well as a nested state machine to accomplish it. This is just using the third-person character template. And to get started, let's do some prerequisites. We'll need a nav mesh so the character can move around. And we will want a new AI character. So if we go to blueprints, blueprint class, character, and we'll just call him AI character. Let's open up that character and assign him a mesh, as well as give him an animation blueprint. So say we're creating an RTS or a JRPG and we have simple commands which we're going to execute for a character. And we know that we want a state machine to do this, as in it's deterministic. There's only so many finite states you can be in. You might be moving, you might be attacking, you might be defending, etc. So to demonstrate this, let's create a new state machine. Call it BP command. And for the sake of example, let's say our first state is to choose target. And then we want to move to target, followed by target reached. And then after this, maybe we're going to attack. Just it could be whatever you want. Let's add a new variable. We want to make this a vector. And so I think what we're going to do is we set the vector here. We validate in this transition the vector is OK. Then we start moving to the target. We check if the target's reached or not. And then we can just go to the next state and you can do whatever you need to for your game. So in the transition out of choose target, let's check to make sure the target is valid. And for this example, it'll be really simple, is valid AI location. And that's just Unreal validating that this is a target within the nav mesh. So we choose a target here. It validates it's true. It'll set to move to target. Under move to target, what we need to do is now tell our context to actually move there. So we're going to assume the context is the AI character that we created earlier. And from here, let's get the AI controller. And let's move to location or actor. And this is a task built into Unreal. It runs asynchronously to this, so it'll actually complete with a delay. And what we can do is just add a variable for simplicity, target reached. Let's grab the target we want to move to. And then let's set target reach to true on move finished. And as a side note, what we'll probably end up doing is switching this over to use a delegate. It'll be more efficient. And also, yes, this node already exists in Unreal, and so you don't need a state machine to do this. But if you're going to create a state machine and you need one of the states to move, this is one way to utilize this. So if we go back here, move to target, we want to exit this when the target is reached. And for our final state, we can just set this transition to always true. And for attacking, let us get our context again. Ask to AI character. And for our move, let's just say jump is the way to attack. So let's test this out. I'm going to grab this AI character, move him in the scene. Let's edit him again. and add in a state machine component. We'll just call it behavior. We'll assign the correct class and start on begin play. And one more thing I want to do before we run this is actually assign the target. Let's have him move to your player character. So if we press play, he runs to you, and then he jumps as his attack. Now, say we're planning on adding to the state machine, making it grow with other attacks like defending or magic or something like that, and we want to clean this up. We can actually nest state machines within state machines. And so one way of grouping this might be considering these two states could be its own movement state machine. And so if you select them, right-click, and choose Collapse to State Machine, let's call him Movement, it is now a nested state machine within this super state machine. And you can see the original states that are there. Doing this on its own, though, isn't enough, because what happens is this will evaluate, and on the next tick, it will switch to the state because this transition is set to always true. Can observe as we play. And he jumps right away, and then he finishes his move. And we don't want that. We want him to attack after he reaches you. So to fix that, it's really simple. We want to wait for this state machine to complete. And the only thing we have to do for that is you click on the state machine, and we can click wait for end state. And then this little guy comes up here, and it signals that this state machine will wait for itself to complete before this transition is evaluated. And now it's the old behavior again. The other option is if you don't want to have this guy checked, you can also do this within the transition itself. And you do that by has state machine reached end state. And it's smart to look back and say, okay, I know that this last state machine movement needs to be in an end state before this can evaluate. Now, what if we want to reuse the state machine for other commands? Like say this is just an attack command, but we also want like a defend or magic or something like that. We can right-click on the state machine we collapsed and choose Convert to State Machine Reference. And so let's just, it automatically names as BP movement. We'll leave it at that. And now, if we open them up, it's a whole new state machine. And it's also smart enough to recreate the variables that we used previously in the state machine. So everything should already be assigned. But this target is technically a different variable than the target we reached here. So what we should do is assign the correct variable. In movement, if we right-click on it, there's an option, Enable Intermediate Graph. And with state machine references, this is like a local graph which points to that reference. So if we right-click, we can grab the state machine reference. In this case, it knows BP movement. And here we can set the target there with the target we chose here. And so we'll set that before it starts it. And one other step is we don't really care about target reached anymore. We can just delete that because it's not even used. Target reached is now unique to the movement state machine. And all we really care about now is if it's reached its end state or not. I want to go back from this and use the other option we had, wait for end state. And this is more efficient because this is kind of like internal behavior where it will know if this is an end state or not, and it won't evaluate this transition at all. Whereas previously it would still have to evaluate it to figure out if it was in an end state. And you can see it still works exactly as before, but now it's technically two separate state machines.